All right, hi guys. So we are working today on graphing sine graphs. Sine graphs. And we use sine to solve for triangles. And that's the big deal. And great, solving for triangles, it's a great tool, but what does this actually look like if I try to graph it out? Now, sine for us, we're gonna use not degrees, but we're gonna use radians. Okay, radians are gonna be x value. And that's gonna be important to us because radians, remember, it goes from 0 to 2 pi to 4 pi, right? We're counting in radians. And we can talk about degrees, like 30 degrees is pi over 6. 60 degrees is pi over 3. We have pi over 2, stuff like this. And we're going to use radians, not just simple x values, okay? So please be aware of that. And sorry. Someone just came in. Okay, so here's what we're going to do. We're going to create a table here. If you guys have a calculator on hand, or yeah, that's a good way of looking at it. If you guys have a calculator on hand, you can try these values, okay? So let's start off with something easy. Sine y is equal to sine of x, okay? And we're going to graph this by plugging in this to a nice, easy table just to start. And then after we learn how to graph it on a table, we're never going to do tables again. Never, ever, ever, okay? So to describe it, we're going to plug in some values. 0, give yourself some space. Oh, no, that's fine. Pi over 2, pi, 3 pi over 2, and 2 pi. These are the values we're going to graph. If we were in class, I would do actually all 17 of them. But since we are in distance learning, we're just going to look at the easy ones. So on the right side, I'm going to graph my unit circle. 0 degrees, pi over 2, pi, positive 3 pi over 2, and 2 pi, back to 2 pi. And I want to ask you, if I give you sine of 0 degrees, was 0 x's or y's in this graph here? The sine of 0 degrees was our y value. What is our y value at 0 degrees? Sine of 0 is 0. The y value, remember we talked about like the sine gives you the y value of the unit circle. So let's just write some points here. This is 0, 1. Oh, sorry, that's not 0, 1. What's wrong with me? It's 1, 0 on the unit circle. It's 0, 1 on the unit circle. This is negative 1, 0 on the unit circle. And over here is 0, negative 1. These are the x and y points on the unit circle. So we've seen this before. So what's the y value? Sine is 0 at 0. What is the y value at sine of pi over 2? That's going to be, look here, the y value is 1, right? The y value, when you're 90 degrees straight up, your fist is at 1. What's the sine of pi? Pi is over here. The y value, hey, isn't this value sitting on the floor? The y value is 0. Looking here, that is 0. At 3 pi over 2, the y value of this point is, look at it, it's negative 1. Sine of 3 pi over 2 is negative 1. Now, if you want, you can confirm this. Thank you. You can confirm this from your graphing calculator, or not even graphing calculator, what am I talking about? Your scientific calculator. So if I take my scientific calculator out, right, and I write sine of 0, I'll get 0. Sine of pi over 2, I will get 1. Sine of pi, I'll get 0. And sine of 3 pi over 2, I'll get 0. And back to 2 pi, right here, the y value will be back to 0. So we're going to change this slightly, and we'll still call this x and y over here. And let's go ahead and graph the points we just talked about. When x is 0, when x is pi over 2, when x is pi, when x is 3 pi over 2, when x is 2 pi. Okay, so this is our x value and this is our y value here. So instead of drawing a circle, which is not the goal here, we're going to open up the circle and graph the circle out. It's almost like we ripped apart an orange and we're opening up that orange. So for every x value, for every x value, we have a y value to graph. For every x value, we have a y value to graph. So every x value, when sine is 0, my y value is 0. When x is pi over 2, what's my y value? My y value is 1. Call this 1, call this negative 1, 1. When x is pi, my y value is back to 0. When x is 3 pi over 2, my y value is negative 1 all the way down. And when my x is 2 pi, we come back to 0. Back to 0. Now, looking here, what you have is actually the basic framework for all sine graphs. And if you can start here and understand this kind of shape that we're going to lay out, this whole chapter will be super easy. Now, please don't do this. Don't just draw little lines here connecting these, because that's not what a sine graph is. It's going to look like, a squiggly line. It's going to be a curve graph. And it's going to be like throwing a ball in the air. Throw a ball in the air, comes down, and then back up. I'm a little off here. Okay, so do this small curve. And not only does it curve up and curve down, it actually keeps on going, and the cycle repeats over and over and over again. Why does the cycle repeat over and over again? Remember coterminal points in a circle? Let's say over here, I start off at 0. So I'm going to yell out the y values as x goes round and round and round. We go 0, 1, 0, negative 1, 0, reset, 0, 1, 0, negative 1, 0, reset, 0, 1, 0, negative 1, 0, 0, 1, 0, negative 1, 0, 0, 1, 0, negative 1, 0. And this goes on for infinity. And these graphs, sine graphs, you might have seen this before. Thanks. We might have seen this before when it comes to music, right? When you see the wavelengths of musical sounds. And they say this is a sinusoidal, right? It comes with this pattern up and down, okay? Mr. goes dancing. So a couple things we want to learn about is that in most math that we learn in high school, there is always a pattern. And if I can read the pattern, I never have to do the table again. A quick example is when we learn how to graph lines. When you learn y is equal to 1/2 x plus 1, okay? If you remember how to graph this quickly, you could, when you first learned it, maybe do a table, and the table's kind of stuck, but you did it. Your teacher told you to do a table, and the table will go x and y, and you plugged in 0, 2, and 4, let's say. Plug in 0, 0 times 1/2 is 0 plus 1 is 1. Plug in 2, 2 divided by 2 is 1 plus 2 is 2. Plug in 4, 4 divided by 2 is 2 plus 1 is 3, right? You could do that. But most of us, if we're asked to graph, we just say, start here and go here. Start at 1 and follow the slope. Rise 1, run 2. Done. No work, no connection to any of the numbers. And that's exactly what we're going to do for sine graphs. If we can find the characteristics of how to make this graph taller, how to make this graph longer, right? How to shift the graph over. All these characteristics are embedded in this simple formula, sine. And we're going to go over the characteristics today, how to change these properties. Okay, so our first thing we're going to do is first make sure we understand the idea of sine. How long does it take me to finish one full cycle for a very basic sine graph? It takes me from 0 to 2 pi. And this is what we call a period. A period is how long it takes you to finish one cycle. Okay, how long does it take you to finish one cycle? What is the period time it takes you to finish your homework? How long does it take you to finish one cycle? This is directly related to a word called frequency for us. And frequency is how many times. How many times, what's the frequency you have to go to pee, right? How many times do you have to go to pee in a day? What's the frequency you have to eat your medication? And I know many of you guys are on medication. What is the frequency that you drink water? What's the frequency you eat food? What's the frequency you take a shower? And we can all translate this back to period. And let's do that right now. So here is our equation for period. Actually, no, we'll come back to it. No, that's just easier. Next word we want to learn besides frequency and period is amplitude. Okay, amplitude in essence is how loud. How loud is this going to get? And the amplitude refers to the distance between the center of the graph and the highest most peak and the lowest most peak. And it's actually going to be the same value. So amplitude for us, A, okay, so let me see this. Amplitude is equal to, we're going to call a letter A here, absolute value of A, because amplitude doesn't care if it's positive or negative. It cares about what's the magnitude of it, how strong it is. But for us, we're going to just simply say A. It'll be easier for us to start. Uh-oh. So amplitude refers to, so let me show you guys visually what amplitude is. It refers to how high or how low this graph is. Now, okay, I'm on Desmos here, and I want to show you something up here. If you look at the letter A on my left, A stands for amplitude pretty much, and this helps me find out how tall this value is. As you can tell, this graph starts at 0, 1, 0, negative 1, 0. 0, 1, 0, negative 1, 0. If I change my amplitude here to 2, getting there. Look at my graph now. 0, 2, 0, negative 2, 0. What if my amplitude became 3? Oops, where's 3? 4. My amplitude is now, come on, forget it. There you go, 3. You notice that the topmost part of the graph is now 3. At pi over 2 is now 3. The lowest most part, negative 3. And as we change the amplitude, so does it respond. Does 0 change? Nope. The zeros don't change. Okay, so that's the first thing we're going to work on. Well, what if it's negative? If it's negative, -1, the graph is actually flipped upside down. And we end up going to flip our values. So something that we're going to notice right now. So where does that appear? So let me go back and give you guys our general principle today. So here's pretty much our standard form. Form for sine. And this will also work for cosine. And this will then also work for tangent. Okay, but every form has something a little bit different. Yes, the absolute value is the amplitude value, but A helps us graph it. And we'll show this right now. So y is equal to A sine open parentheses, bx minus c, close parentheses, plus d. Okay. So where does a sit? A sits right in front. So if I write you a problem, y is equal to 2 sine of x, the amplitude is now 2, positive 2. So the graph, so I want everyone to see how easy these graphs can be drawn. First, draw your cross, your fallen cross, and I want you to draw 4 extra tick marks. If we're starting at 0, I want you to give me 1, 2, 3, 4. That's important for me. The period for this basic graph is going to be 2 pi, so write 2 pi at the very end. What is half of 2 pi? What's half of $2? Half of it is $1. What's half of $1? 50 cents. Now, I need to tell you what this tick mark is going to be. And we're going to count. If each tick mark is 50 cents, that's going to be 3 quarters, or 3 50 cents, sorry, not 3 quarters, 3 50 cents. 3 pi over 2. So every time we graph this, we're going to do the same process over and over and over. But right now I'm going to show you how does this 2 change our graph. So here's what happens. 0, 2, 0, negative 2, 0. It is now 2 spaces up. Now, I want to show you guys how I'm graphing this. To make a nice sine graph, you need to follow the curve, okay? So please watch. Start from 0. Draw a curve like you're throwing a ball up to 2. Take off your pencil. From 2, drop your ball, throw your ball down. Take your pencil off, restart. From pi, from 0 all the way. So you make this like parabola looking thing, stop, and then start your parabola back up. And this graph continues to go. Let's go backwards. I'm going to give you a graph and you tell me what number I should write. Y is equal to blank sine of x. Draw this out. I'm going to draw 1, 2, 3, 4 tick marks and 2 pi. And we're going to start 0, up, 0, down, 0. I'm going to draw the curve for us. Because all these sine graphs look the same. What happens is the tick mark changes. I'm going to write 1/2. What do you think my a value is now? If I told you it goes 0, 1/2, 0, negative 1/2, and 0. So my amplitude now is 1/2. So my a value is going to be 1/2. If you want me to do 6, here, let me show you 6. That's sine with a 6 in front of it. Amplitude is one of the easiest ones for us to discuss. Now, I'm going to trip you guys out a little bit. I'm going to change this. Y is equal to 1. Oops, I want to leave it blank. Sine of x plus 2. Now, I'm going to show you how this graph is reflected. 1, 2. 1, 2, 3, 4. I'm going to draw this graph. 0, up, 0, down, 0. Can you tell me what is the amplitude of this graph? Is it going to be 2, 4, or 0? I'm hearing 4, I'm hearing 2. Now let me re-describe what amplitude is. Amplitude is the distance from the center of the graph to the very top and to the very bottom. It's the same number going up and down. So from the center, it would be 2 spaces up, right? That's how I went from 2 to 4. It's almost like I stuck the graph in an elevator. and the elevator moved my whole graph up. Now it's on the second floor. Imagine if I took you on an elevator and your head is your top and your toes are your bottom of your sine graph, and you hop in the elevator and your head is still on the first floor. Right? It goes along right with us. So this is now positive 2. Here's something kind of cool. I wrote 2 here, right? Because that's how much I moved the graph up, by 2 spaces. So let's go back and take a look at the other letters that are here. We have an A, and let's go back and look at it. A is for amplitude. It really isn't exactly amplitude, but it helps us find the amplitude. D is going to be our vertical shift. And as you saw in my last example, what was my D value? My D value was +2. That means the center of my graph is now at 2. If I want to do this example again, I'm going to write y is equal to 2 sine of x minus 1. So to show you guys the relationship, the graph is now -1 step down, dot, 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 dot. Draw my 1, 2, 3, 4. Right? I really have 5, but the 0 counts as one of them. And I'm going to put these on marks here, just talking about it right now. And from the center, we're going to go 2 spaces up, 0, up, 0, down 2 spaces, and then back to 0. So look at this graph here. This graph is still, the amplitude is 2. Still 2 and still 2. But I shifted the whole graph down by 1. Can you go to the basement for me? So 2 things are automatically taken care of, our A value and our D value. Those actually are our easiest values to consider, our A and our D. The B and C, a little bit more tricky, but each of them will play a role in deciding how this graph looks in the end. Just like slope-intercept form in Algebra 1, it helped us decide what my y-intercept was and the slope, right? Rise and run. So let me continue with some more examples to hopefully help you see some relationships here. So in this example here, what would number 2 and what would -1, which letters would I use to represent it? If you have your notes, you can take a look. A is in the front and D is in the back. So your A and D values in our original parent function automatically tell us how to start this graph. If I write y is equal to, let's do 3 sine of x plus 2. Okay, so right now I'm going to go ahead and show you my method of graphing. I always first draw my graph, and then I actually work this way. Start here. You guys ever go subway and it says start here? Whenever you walk into a subway, it always looks the same, but you start at different sides depending on what subway you go to. But they always have a sign that says start here, so start here. Start at 2. My vertical shift is +2. So I'm actually going to count 1, 2. I'm going to draw a line out like that. Sitarth, that's right. So I always start here. So I always say, hey, what floor am I on? So up 2. My next move is working right to left. We're going to see this right now. This is going to give me something called the period. And we'll work on this. We'll come back to it. We mentioned it just a moment ago. But my period here is going to take me 2 pi to finish. So from 0 to 2 pi, there's not going to be a shift here. No moving back and forth. We're just going to start off at 0 first. If I start off at 0, I'm going to end at 2 pi. Now, you're going to do this move. Cut 2 pi in half. Where would you put half? Is that half? Is this half? Where would half go? Come on. Half would go right here. And isn't half of 2 pi just pi? everyone is doing these tick marks. We want to make sure our graph is nice and proportional. I do not want to see graphs that look like this. Okay, I don't want to see graphs that are butt heavy. Ooh. Okay, I want graphs that are nice and proportional. How do you do that? You make check marks along the way. You guys ever go on a tour and you plan out when you're going to stop? That's what we're doing. We're planning out. So we're going to cut 2 pi in half, and I have a slogan for this. I call it half, half, and half. Half, half, and half. So we're going to cut this in half, half, and half. So what's half of pi over pi? Is pi over 2. Then we count 1 pi over 2, 2 pi over 2, 3 pi over 2. Half, half, and half. That's how we end up with our 4 tick marks. And this will be more important later. And now we have the spacing of the graph. I want you guys to copy, please. Copy the tick marks to your vertical shift. I'm not sure you guys can see that. Let me do this in red. Red, 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 red. Okay, I copied them over. Because remember, didn't this graph get lifted up by 2? It's like a roller coaster. All the points got lifted up. Now, working forward, we are now at A now. Now here's where, this is the easiest part now. You're going to count from our new center here. Count up spaces 1, 2, 3 up, and please draw a dotted line across here. Because that's our roof. That's the highest we can go. That's our ceiling. Okay? Don't call this extra work. I'm trying to make sure your graph looks super nice. We went up 3. The amplitude also says go down 3. Count 1, 2, 3. Oh, we are underneath. We're in the basement here. So if you notice, I have an upper bound and a lower bound. And the graph is going to go someplace in between those bounds. Don't get annoyed at me saying, yeah, I'm making you do too much work. I'm really not. I'm just trying to make sure your graph is nice and level. I don't want to see graphs that go up and then, oh, look, whoa. That is not a graph for graphing. Now, here's the next thing. Sine and cosine actually have different starting values. And we'll worry about sine now and cosine later. But sine always makes you feel like a 0. Sin makes you feel like a 0. So we're going to start right in the middle here. But it's 0 plus 2. That's why we're 2 spaces up. So sine always starts in the middle of our current graph. So 0, up, 0, down, 0. And those are our points we're going to follow. I have my stopping points along the way, and we're just going to follow it. Curve up, stop, curve down, stop, curve down, stop, curve up, stop. And give yourself little arrows on the outside. And this is our graph. Now let's go back and look at Desmos after you guys copy this. I'll give you guys in a couple of seconds. So Desmos here has out some letters laid out. Is this the right one? Oh yeah, they call it C, but I call it D. And then I want to show you something kind of cool. Let me reset this. Okay, this is our sine graph. If I change A, whoops, do you see how it's making it stronger or weaker? If I change my, this, they call it C, but it's really D. Look, it just takes the same graph and then moves it up and down. Now our graph we said was 2, and our A value was 3. If you look at this graph here, the highest point is 5, the lowest point is -1, and this is the graph that we drew here. Highest point is 5, lowest point is -1. So we drew what Desmos drew, and our goal is to be able to draw this by hand. Okay, we're gonna do this one more time. Okay. Except I'm going to teach you a new letter now, and that's going to be B. A sine of bx plus c. I didn't write a parentheses, so no, whoop, that's a D. So no C. No C. So B for us is going to be B helps find the period. The B value actually stands for what we call frequency, and I'll explain that right now. It's going to go back and forth a little bit, but the B stands for frequency. But let's go ahead and get started here. So your period equation, the period is equal to 2 pi over the letter B. 2 pi over B. So for the problem, y is equal to sine of x. A is 1. B is 1. C, no C is 0. D, no D, D is 0. So these are the letters that we will write for all our problems from now on. A, B, C, D. A, B, C, D. A is my amplitude. D, we said, was my vertical shift. B is the letter I'm introducing you now. That's called my period. Oh, it's actually frequency. B is actually the frequency. But then we don't use frequency. I'll tell you guys why right now. We use period instead because period is so much easier to graph and to talk about. Okay, it's so much easier to talk about. So here's what we see. We see B here is 1. Let's plug in 1. The period of this function is 2 pi over B1, which means it takes 2 pi to finish. If you look at all the graphs that I've been drawing, they always start and stop in 2 pi. Let's go back and take a look. 0, start, stop at 2 pi. 0 to start, stop at 2 pi. Because the value in front of x, my B value, is 1. So all my examples here have been starting and stopping at 2 pi. So what happens when I change that B value? Let's go take a look at decimals real quick. This B value is 1. I'll show you something here. If I make my B value increase, look, it's making my graph either shorter or longer. Shorter or longer. Shorter or longer. So how am I supposed to deal with this? And all we do is we take our equation and we say 2 pi over B. So for this equation, I'll show you something kind of cool. If my B was 2, P equals to 2 pi over B, all right? If my B was 2. If I plug in B is 2 pi over 2, what cancels out here? The 2's.
The numbers.
The number's right, and we're left with only pi. So how long does it take me to finish my graph? Sine of 2 pi. If B equals to 2, P equals to 2 pi over B, which is now 2, my period is pi. Take a look at when I start to when I stop. It takes me pi to finish. So all you do is you plug it into this equation, 2 pi over B, and you know where you're starting from, and you know how long it takes you to stop. So what if this was 1/2? Or 0.5? Look, I just made this graph super long. So what happened? When did I finally stop? Let me just shrink this a little bit. From starting to stopping. Oops. P is 0.5. There it is. Let's take a look here. Where is my final stopping place? Can you guys see this? It stops at 4 pi, right? Because I'll see I start at 0 and I end at 4 pi. So let's come up with that number ourselves. My equation for period, how long does it take me to start to stop the graph? P is equal to 2 pi over B. We said in this that my p-value was 0.5, or let's say 1/2. 2 pi over 1/2. We don't like dividing fractions. We multiply by the reciprocal instead. It's equal to 4 pi. That's where we stop. Without doing a horizontal shift, the b value tells me when to, helps me find where to stop. Now, what is b really? B is frequency. So if B is frequency, what does frequency even mean? Frequency means how many times you see something over a given period of time. Common questions that a doctor might ask you. How many times do you pee in a day? That's frequency. How many times do you drink water in a day? Right? How many times a day do you drink soda? That's frequency. Now, a pharmacist might tell you this. Now, listen to this one. This one actually makes sense a lot more. A pharmacist will tell you, eat 2 pills every 24 hours. Eat 2 pills every 24 hours. Is that a frequency or a period? Eat 2 pills every 24 hours. If I tell you eat 2 pills, that is a frequency. Okay, let me write this down. If I ask you to eat 2 pills every 24 hours. Okay. This is a frequency. But what is the period now between each pill? And this is a question I get from elderly people who I'm helping out. They'll say, the doctor told me eat 2 pills every 24 hours. I don't know what that means. Do I eat it 2 pills at the same time? Right? Do I eat 2 pills together? Do I eat them one before lunch, one after lunch? And Christian wrote it, a period is how long in between. So it's 12 hours each. So how do you do that? You take 24 and you divide it by 2, and that's 12 hours. So what we're doing, we're going to do essentially the same thing. How long does it take you to finish one sine graph? One sine graph is done, the period is done in 2 pi. Okay, this idea. So if b equals to 1, if I want one sine graph, it's going to take me 2 pi to finish. But what if I want 2 sine graphs in the same amount of time? How long does it take me to finish each of those sine graphs? How many do I have to squeeze? I need to squeeze 2 into 2 pi. So how long is each of these sine graphs? It is pi each. What if I want to squeeze 4 of these? B is equal to 4. That means, let me draw this out. This is easier to look at. Here is 0. Here is 2 pi. If I told you draw 4 of these in here, draw 4. That's going to be hard to do, right? So oftentimes we're so careful. Oh, that's 1, 2. Dang it, I only got 2 in there. So you got to redraw it. 1, 2, 3. Dang it, I only got 3 in there. So here's what they came up with. They said, just use the period formula. P is equal to 2 pi over 4. If I reduce, it takes me pi over 2 to finish. Here's pi. Half of that is pi over 2. And 3 pi over 2. So that means I have to finish 1, 2, 3, 4 graphs in that same amount of time. So we're going to put these steps together right now, and I'll show you guys how to graph them all together. Y is equal to 2 sine of 2x plus 2. Mr. Ko, why'd you have to put all those 2's? A, B, C, D. Please right now, if it's possible, go ahead and write down, fill this in. What is my A value, B value, C value, and D value? I'm going to write here is your parent function. Y is equal to A sine bx minus c plus d. If you don't have a value, you are allowed to write 0. A is 2. B is always, I promise you, always bonded to your x. Always the number in front of the x. That's a 2. No parentheses, no c. And d is by itself. It's a positive 2. These are the characteristics we are going to graph for this sine graph. As I mentioned before, like Subway, we start from the end and work ourselves forward. Start here. So everyone draw a graph. Please draw some arrows here. I'm gonna walk you through this, and you can watch this over again on the YouTube video if you need to. We start with D. D we called our vertical shift. That means it's gonna raise or drop our graph. So we better draw this first. So I said positive 2, up 2, then draw a dotted line. No joke, please draw that dotted line. This is our new home. We live on the 2nd floor. C is 0, that means there's no phase shift. And we'll do this later because phase shift is the hardest thing to graph on sine graphs. Mo, go away. B is frequency, but we use it to find the period because period is so much easier to graph than frequency. 2 pi over 2, remember 2 pi over B? It's going to be just pi. So we graph D already. Now we skip C because we know we're going to start at 0. Here's 0. And when do we end? We end at pi. So this is what you do. Just make a mark and call that pi. Start at 0, end at pi. Everyone see that? Start at 0, end at pi. Once you have your beginning and your end value, we now graph our half, half, and half. So we do half, half, and half. We do this because we want our graph nicely spaced out. Okay, if you need to watch this over again, watch the YouTube video, okay? Start here, just watch this part over again. Half, half, and half, and now I copy all the tick marks onto my D value because this was lifted up. Copy them all onto my D value, right? These are just space holders for me. My last part is A, the amplitude. We said it's +2, so we're gonna go up 2, put a dotted line, and then down 2. Down 2 takes me back to 0. Now please realize the graph is now stuck between my bumper bowling. You guys ever go play bumper bowling? They throw up these little gates on the side and your ball just goes bong, 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 and it never gutters unless if you're super unlucky. Me. So now we went 2 up and 2 down. So we have that guideline so where this graph must fit. Now last part, let's go ahead and graph it. Sine always starts at 0. But remember my 0 was lifted up right here. And at my first gate, sine always goes up because it's positive. Sine up, 0, down, back to 0. 0, up, 0, down, 0. 0, up, 0, down, 0. And hopefully you see the pattern. Up, down, down, up. And that is your sine graph. And this 100% represents this graph here. Don't forget to draw your little arrows. If you want to continue, this graph goes on again. Make sure you copy the spacing about right. That's about 2 pi. Half, half, and half. Copy your tick marks. 0, up, 0, down, 0. 0, up, 0, down, 0. And then this graph continues on forever. Backwards, remember, keep your distance. This is going to be negative pi. Half, half, and half. Going backwards, 0, up, 0, down, 0. Okay, all right. Hopefully that was helpful. We're out of time. If you want to stick around, I can help you guys out a little bit more. But if you want, you can also watch the video over again, and I think that would be helpful. Thank you.